So this is the worksheet 2, which is on tomorrow's link. So we have a position function that's given by x of t. It says show that the velocity is equal to 2 minus e to the t, or sorry, 2 minus 2t over e to the t. So it's already giving us the answer for velocity, but we're going to go through that process, right? So here's position. Okay, so I want to find a derivative to get from position to velocity. So what, I'm sorry, I wrote down the wrong one. Okay, so we're starting with this. If I want to find my velocity, I have to involve what? To find a derivative. Involved here. Any special rule? Well, is it product or what? Numerator and denominator, so we use what? Quotient, right? Quotient rule, right? So quotient rule to find the derivative. All right, so let's see if we can fill this in. F prime. Two. G function, no changes. Back to F, no changes. Okay. What's G prime going to be? What's the derivative for e to the t?
Wait, is that e to the t?
Yeah, that's e to the t. I can show the rule here. Where's the rule? The rule for e to the u is e to the u times u prime. So does that help?
Does e to the t times 1.
Yeah. Which is just what? Yeah. All over. Okay. G squared. E to the t. And what does that become? What do we do if we see two exponents next to each other? You're going to multiply them. Yeah, multiply them. Now, if it was the time that you added, if it was e to the t times e to the 2, then it'll be, then you add them together. But if you see exponents directly next to each other, just multiply them. So okay. What can we do to clean that up? Roy, what do you think? Is there anything that we can maybe? Yeah, take out e to the t. And then? Does that reduce anymore? Think of e to the 2t as e to the t and, right, so e to the t squared is really e to the t and e to the t, so there's two of them here. Yeah, we can take out one of them, right? So does that match our answer for velocity? Right, so that matches what we're trying to achieve, right? Okay, for part B, now we want to find the acceleration function. So to get from velocity to acceleration, what do we use? Mm-hmm. And what method would you involve? Yeah, quotient rule again. Yeah. So try that. Let me see your work. And then see if you can clean up to make it match what they present you. Good, keep going. this is what I had here. Negative 2 e to the t. Negative 2 times e to the t is negative 2 e to the t. And then negative times negative 2t times e to the t is going to be a plus 2t e to the t. Is that what you had?
Plus
I think
2e t to the t. Or plus
2t e to the t. Yeah, it's not t to the t, it's e to the t. Right? 2t.
Okay.
Took out negative 2 e to the t, that works. It's 1 plus 1. Yes, I think that works. Yeah, and then combine some like terms there. Okay, and then so you get negative 2 or negative 4 plus 2t all over. There we go. Yep, and that matches our acceleration. Good, good, good. All right, so we have our velocity acceleration. Moving on. For what values of t is our particle at rest? So how do we achieve that? How do we, or where do we look and what do we do to find when a particle is at rest? So what does at rest mean? Close, not acceleration, but what? So we set velocity equal to 0. Right? Set velocity. So if I want to find particle at rest, we set velocity equal to 0. Now, we have a couple of parts for velocity, right? So what parts of velocity do we set equal to 0? Do we set the top equal to 0? Do we set the bottom equal to 0? Do we set the whole thing equal to 0?
You set the top.
Just the top, yeah, just the top. So t equals what? 1, yeah. Let's skip down to E here. For the same part C, is the velocity increasing or decreasing? So remember in class today, how do we determine if a velocity is increasing or decreasing? What do we look at?
You plug in numbers, like multiple numbers.
That's if we want to do a sign line. But if we want to just find out whether velocity is increasing or decreasing. Okay, but which function would you use? Acceleration or velocity? Roy, what do you think? Acceleration, yeah. So you see the word velocity. I know that's kind of misleading, but then there's increase, decrease. So that's really taking the velocity and talking about the rate of change of it, which is really acceleration. Yeah, so we're going to look at acceleration. So find acceleration at 1 and see if it's positive or negative. If it's a positive acceleration, then velocity is increasing. If it's negative acceleration, then velocity is decreasing. Okay, what do you guys conclude? Okay, let's plug in 1 then for acceleration. Mm-hmm. Right, it says for the same value from part C.
Oh, use that.
Yeah. Negative, right? Okay, so we get a negative acceleration, so therefore velocity must be decreasing, right? Because acceleration is less than 0. All right, for yeah, let's skip F. Let's go to G. What is the velocity when acceleration is 0? This is the 2-part problem here. How would you begin this process?
Load acceleration 0.
Okay, so how would you set that up?
You do acceleration equals 0.
Okay.
You solve for time.
Solve for time.
And then you plug the time into the velocity.
There we go. Yeah, good. 2-step process. Good. First step, set acceleration equal to 0. And what did you find for your time? Yeah, how do you do that? Okay, we can cross multiply. But to make this match, maybe you make that 0 over 1. So you could cross multiply. Or you can just think of it as, well, acceleration equal to 0 is really just the numerator, right? The denominator is not a part of my process, so just the numerator. But you can cross multiply and convince yourself of that as well. You get 0 equals 2t minus 4. So what's the time that we're looking at here? 2. So we have the time. Now we can finish the rest of it, right? What is the velocity? Yeah. Do we have the velocity equation?
Yeah, it's 2 minus 2t
So how would you do that?
-4 over e2 or e squared.
E squared. Let's see. Here's my velocity function. Good. Yeah. So -2 over e squared. Yeah. There we go. Let's look at part I. At t equals 3, is the speed of the particle increasing or decreasing? So how do we approach increasing, decreasing speed? Say it again? Good, compare, right? Compare signs. Yeah, good. So find acceleration at 3, find velocity at 3, and see if we can decide how the signs are pairing up. Okay, what do you know about velocity? Positive or negative?
No, it was negative, right?
Yeah. How about acceleration? Therefore, what can we conclude? Say it again? Good, decreasing speed. Yeah, yeah. Yeah. All right, good. Maybe we can target another problem tomorrow and then just do a topic a day or something. But yeah, I'm also available